Final fuel product, helium, is a completely inert substance that is not radioactive and not therefore dangerous and has to be stored for any particular length of time.
This is a tokamak. Inside the circular tube, the protons and neutrons, heated to very high temperatures, turn into plasma.
The plasma is considered to be the fourth state of matter. If you take a gas, which being sort of the third state, starting from the bottom liquid, solid liquid gas, and heat it up further, and it starts to actually come apart internally into its electrical constituents, you get what's called a plasma, which tends to be luminous. Quite often, the gas inside a fluorescent light tube is a plasma. The sun is a plasma.
Can you just put this plasma in some kind of metal container for the reaction to take place?
No, there's where you have the problem. You must insulate it from its walls. So you have a plasma which may be at millions or tens of millions of degrees inside a container. So to insulate it from the wall, we need some other kind of inner containment.
Because it's too hot?
Yes.
The wall would melt?
Simply melt the wall or cool the plasma. That would be the same thing.
Okay.
So to keep it hot and insulate it from the walls, you insulate it with, in our particular case, magnetic fields to keep it separate, keep the heat in and the walls cool.
What's the shape of the tokamak?
In particular case of the tokamak, there are many magnetic configurations, but the tokamak itself is a donut-shaped configuration where the magnetic field lines go around in a circular manner. There are several decades before we would ever have a real power-producing or certainly commercial reactor. We have to take it a little bit at a time and learn from each series of experiments how to best do the next series.
Is fusion the solution to the energy crisis, or is it just a myth tangled in a web of complex technology that will continue to elude scientists? The answer lies in buildings like these, where research goes on to turn fusion into the energy of the future. This is Leora Frucht at Hydro-Quebec's Research Centre in Varennes.
Joining me in the studio now is Dr. Fred Knelman, a professor of science and human affairs at Concordia University. Professor, welcome to the show.
Thank you.
My first question, what about fusion? Can it work?
You know, as a scientist, it is very rare to feel certain, and almost nothing can I say I am certain about. But if I could say I was certain, I would say that never, not just in the second millennium, as most people are predicting, that is somewhere 10 years into the year 2000, but I would say that you will never see a commercial kilowatt hour of energy from a fusion reactor in any time in the future. It is a hoax. It's confusion, really, not fusion.
Why might that be?
Well, the University of Wisconsin has done a series of fascinating studies with nuclear engineers where they imagined a fusion commercial reactor, you know, generating 1,500 megawatts of power or 2,000 megawatts.
Serving households everywhere?
Yes, yeah. And they then asked themselves, what were the engineering problems that they would face? And the conclusion was that if you could solve the engineering problems, in which there are still incredible unknowns, materials that they don't have, design which is uncertain, but the cost of that reactor, if you actually wanted to contain the reaction, would be prohibitive. As a matter of fact, the lowest cost they could come up with for a large fusion reactor would make electricity 3 times the cost of the next most expensive source. So in other words, I don't think it's serious. And there's a way of judging this operationally, incidentally. I happen to just recently be doing a study comparing energy policies of 50 countries. And I got the latest figure from the International Energy Agency, the figures for the research and development budget. And this is where they're putting their money on future sources. And the vast proportion of the budgets are going to what are called breeder reactors.
Which is what?
Which is a type of nuclear reactor, like a conventional one, but it actually creates more fuel than it consumes. It creates plutonium. And this is where France, Britain, Germany, Belgium, the Soviet Union, despite everything they say about Soviet Union being advanced in fusion, they're putting all their resources into breeder programs, or 90% plus of their resources.
What are breeder programs exactly that you're mentioning here? Are they more...
Well, the advantage of them is, you see, uranium is a limited resource. It is really, there isn't that much more uranium than oil in the world. Okay. So we're only talking about 20, 30 years of supply at current use, okay? So the ordinary reactor, like the Gentil 2 that they're going to start up, which uses uranium, has a limited future. So if you're talking the long-term future, you have to look at sources which are relatively inexhaustible. Incidentally, you know what the thickest book in the world is, don't you? The Lies Hydro-Québec Tells. Because even that film, it's disgusting. Because you see, in a star or a sun, the fusion process is the fusion of two hydrogen nuclei, of hydrogen atoms.
Okay.
Whereas the tokamak is two synthetic, well, one synthetic element, tritium, and one in which, in seawater, it has to be taken out at great energetic cost, because only one part in 5,000 of seawater is deuterium. Okay. Secondly, the fusion reactor uses two other critical elements, lithium and helium, which are in relatively short supply. So to call it inexhaustible, you know the law of the minimum. The law of the minimum is ecological law. If I want to support 1 million people, and I have the housing for 1 million people, I have the transportation for 1 million people, I have the food for 1 million people, but I only have water for 250,000, that's going to determine the support system of the population, the critical element.
But seawater is so much in abundance that
But that's not all that's used in fusion. A fusion plant is a physical designed entity which uses other materials. And it's the other materials that are the minimal. It's the law of the minimum again. They determine how exhaustible or inexhaustible. So you can't determine it by the amount of seawater you have. You have to determine it by the amount of lithium you have. And lithium is limited.
Is it possible to regenerate any of the elements required to...
Well, you regenerate tritium from lithium. But that's not the point. You still do not have enough helium or lithium to call it inexhaustible. Solar energy is inexhaustible. Hydrogen energy might be inexhaustible. But the way people are... You asked me about the breeder program. Where people are putting their money and where their mouth now is, the so-called experts in future energy, is on this breeder, because they feel that is the answer to depleting oil resources.
So what do you think we'll be using in the future then?
Well, I think that that's also a very, very negative approach. You see, now it's almost beyond, well, it is beyond argument. There have been impeccable studies to indicate that of all the supply options we have in the short term, the next 10 or 20 years, of all of them, the most cost-effective, in effect the cheapest, BTU for BTU, or kilowatt hour for kilowatt hour. And not only that, the most labor-intensive, that is the one that yields the most jobs for the least dollar investment, is conservation and efficiency.
Well, thank you very much, Professor. We'll be back with more on Futurescope right after this. There's more to see in movies these days, but there are also things that you don't see.
When you see an actor running in a movie, you know that someone had to have been running alongside to film him. Running isn't usually smooth, yet you never see any evidence that the camera was bouncing around during the filming. That's because it wasn't, and that's because of Steadicam. Futurescope's Marisa Tanieri has this report.
I'm at the Canadian Light Show, and I'll be speaking to Mr. Ed Clare, who's a representative of Cinema Products. He'll be speaking to us about the new Steadicam. Mr. Ed Clare, how did this all get started?
Well, the Steadicam is an invention of a Philadelphia-based filmmaker named Garrett Brown. And if you look back at the history, recent history, I should say, of motion picture equipment, you'll see that in the late 60s and the early 70s, there was a trend toward lightweight production equipment which could be used on location. And they had a type of filmmaking called cinema verite, which was quite popular in the late 60s. And the only problem with cinema verite was that on location, when they were using the cameras, they tended to roll and they tended to rock in a fashion that was very unnatural and was somewhat disturbing to the audience. So there were a few filmmakers who were trying to come up with some sort of device that would take the rock out so that you wouldn't have this effect on the screen. Garrett Brown was working on a production, and he came up with a device that was good for him.
So let's describe this device.
Well, I'll try and describe it in terms that are not too specific and not too technical. But the Steadicam is basically a mechanical device. And what is required is that the camera operator wears a vest over his body, and the camera is attached to the vest. Now, I think one way that people can understand how the Steadicam works is to think about a person walking down the street with a glass of water. You know, the body is a very good servo system, very excellent at compensating for uneven terrain or stairs. So if you were to walk down the street with a glass of water, basically holding it out in front of you, you would probably not spill a drop. You'd be able to walk for blocks and blocks and not spill any. On the other hand, if you were walking down the street with a gallon of water, after a while your arm would get tired, you would begin to shake a little, and maybe you would even drop the gallon of water. So when you think of the Steadicam, you think of, well, here's this vest and here's this support system, which is taking the weight of the camera off the camera operator. It's supporting the weight of the camera, and the camera operator feels like he has nothing more than a glass of water in his hand. And he's free to concentrate on the cinematography and the lighting and the dramatic aspects, and he's not thinking about the camera.
What camera shots are unique to the Steadicam?
On the screen, the viewer is treated to new and different type shots, exciting shots that he wouldn't have otherwise have seen.
I would imagine that this camera would also make shots of motion shots in terms of running and sports.
Yes.
This would also be very...
Yes, these are one of the primary applications. Now, for example, what this does for the production crew is that it means they don't have to set up dollies, they don't have to set up elaborate track, they don't have to hire in very expensive equipment. Not that the Steadicam is inexpensive, but it allows them to shoot on location without the full complement of equipment that they might otherwise have to bring. And you know, here you have one man with a Steadicam on, and he's able to run through the lot, run into a building, run up steps, walk. He's able to come to a stop. He's able to hold a shot. Just as we're sitting here and we have a camera on a dolly, he's able to achieve that effect as well. So the Steadicam is extremely versatile, and it allows these cinema people and the producers to achieve results and achieve shots that they perhaps wouldn't otherwise be able to do, or at least not be able to do economically.
Do you think there are certain limitations, other than all the advantages we've spoken of? Can you think in terms of limitations?
I'll have to think hard, but I can come up with one or two. For example, you know, with any good cinematographic tool, it can be overdone. You can have situations where there's too much Steadicam, or where there's Steadicam simply for the sake of Steadicam. Don't forget, the point of the film, the point of the tape is to entertain the viewer and to get the message across, whether it's entertainment or information or whatever, not to distract the viewer with the technology. And so you have situations where you either have people who are inexperienced at using the Steadicam, or where they tend to overdo it. For example, when the zoom lens first came out, there was a tendency to overdo the zoom lens, and we in the industry call it tromboning, where you zoom in, zoom out, zoom in, zoom out. Well, you could have the same thing happen with the Steadicam. You run in, run out, run in, run out, and overdo it. A second limitation is that because you have new freedom, you now have an ability to move a camera in ways that it couldn't be moved before. You have the possibility for going outside of the lit area, and you have the possibility of it picking up things that on the camera that shouldn't otherwise be captured by the camera. So there are a couple of limitations.
Besides using the Steadicam for video and film, would you think there are other industries which could benefit of this innovation?
Well, Marissa, I think we have sold a few units to people who own still cameras, interestingly enough. You probably wouldn't expect it, but For example, we sold a couple to the United States government where they mount a still camera with a very long telephoto lens, and they're able to use the Steadicam. They're able to use the Steadicam shooting out of helicopters and so forth for reconnaissance work. Another customer of ours is the Israeli government, and they're able to mount the Steadicam in their jets or on jeeps that are driving along on the desert, and again, they're able to use still cameras with long lenses and do reconnaissance work and get very steady and very crisp pictures that they wouldn't otherwise be able to get.
Back to the film and video. What's next for Steadicam?
That's a good question. We are in the process of developing another model of Steadicam, which will make it even a little bit lighter and a little bit more versatile. For example, in the last 2 years, we have developed an upside-down bracket for the Steadicam, where instead of having the camera at eye level, you're able to have the camera at the ground. For example, it was used most recently in The Shining. You had some scenes where the little boy is riding around on his tricycle as he rode through the mansion, and the Steadicam was able to follow him and give you the point of view of the little boy. And we often call that the dog shot, because you're actually at the point of view of a big dog. So we have developed that. We have developed a mount to allow them to mount the Steadicam on a boat, for example. It was used recently on some river rafting expeditions in the Colorado River. I should also say, if I might, just add a word about my company, Cinema Products. Because we're in a very competitive environment, and because there's constantly new technology on the horizon, we have to be aware of what's being developed, what our competitors are working on, and what our competitors are thinking about. So we cannot stand still. Just like any company, even if we think we have a good thing, we have to be looking for ways to improve it. And we're very fortunate in that we have a very good engineering department, and that they continue to take an open view of these things, and they continue to listen to the inputs that the people bring back, that the customers bring back, that the producers bring back, and so forth. And we take all this and we try and come up with new ways of refining each product that we work on, and especially Steadicam, where we have worldwide distribution and where we have exclusive development of the product. We really have an incentive to go out and take it to its fullest, so that it becomes something that becomes as commonplace as a tripod, as commonplace as a zoom lens, and it becomes something that everybody in the professional industry can use.
Mr. Clare, thank you for having shared this technological information with us.
You're very welcome, Marissa. Thank you for having me.
I'm Marissa Tanieri, reporting from the Canadian Light Show.
Steadicam may not seem as spectacular a special effect as a Steven Spielberg movie, but it has proven to be an important innovation in the film industry, maybe more important than a Spielberg stunt. Movies are supposed to reflect today's society. Spielberg's movies often surpass reality as we know it, but Steadicam allows us to see actions we can all identify with, and it has won an Academy Award for advancement of cinema technology. It seems that nothing is just a calculator anymore. Now the newest calculator can also compute your daily biorhythms.
This is the Cosmos Mini Bio from CompuCenter. It gives you world and local time, serves as a calendar, and will keep track of your biorhythm for life. I'm Peter Garrett.
I'm Karen Joy Seidman. We hope you'll join us again on Futurescope.